we're going to talk about angles of rotation, which means we're going to draw angles in standard position, and then we're going to determine the values of trigonometric functions for an angle in standard position. So we're going to do some sketching of angles. So the angles in standard position, right? So these are a couple representatives of angles in standard position. If it's a positive rotation, then the initial side is always on the positive x-axis. Okay, so that's where it starts. And if it's a positive angle, it's going to rotate around counterclockwise until it gets to its terminal side, right? So the blue side here is the initial side. The red side is the terminal side. So here it demonstrates a positive 135-degree angle. The one over here on the right for negative rotation, the initial side is still on the positive x-axis, but if it's a negative angle, it's going to go clockwise. Right? So and you can see that they show in the positive, they show the arc here with the arrow. They show with an arrow to show you which direction it is going. Now notice that we have also what shows around here, we have 90 degrees, 180, 270 with the positives. And with the negatives then we have negative 90, negative 180, and negative 270. Right? It's all the way around the circle is how far? 360 degrees. Right? So if I go all the way around, we're at 360 degrees. So an angle of rotation is formed by rotating the terminal side and keeping the initial side in place. Notice here then they show an angle of 390 degrees. So it shows that it had to go all the way around once, plus it went an additional 30 degrees to get to the 390 degrees. But we still only show, so we have the initial side on the positive x-axis and then the terminal side. But we have to show all the rotation, so it could go around more than once, right? For angles that are bigger than 360 or angles that are less than negative 360 degrees. Okay? So the first thing we're going to do is we're just going to draw angles in standard position. So we're going to start with these three, 320 degrees, negative 110, and 990 degrees. So the first thing you're going to do is put these on your paper and then draw a set of coordinate axes so that you can use them to make the angle. Okay, so we have a positive 320 degrees here. Now the one thing to understand is that we have, this is 90, 180, 270, okay, and then all the way around would be 360 degrees. So our initial side goes on the positive x-axis. All right, and this is going to terminate at 320 degrees. Now, you don't have to be perfect with these, okay? So when we go around, we got here's 90, 180, 270, and now 320 would take us about another 50 degrees, right? So a little bit over halfway. So it's going to be a little bit closer to the x-axis than the y-axis here. And so we put an arrow there, and then I draw my terminal side. And this would be a positive 320 degrees. For negative 110. So that means we're going clockwise now. So we put our initial side on. And here we got negative 90, negative 180, negative 270 when we're going clockwise because it's negative. So negative 110 is going to be just a little bit past negative 90 degrees. So we're going to go just into the third quadrant here, and we draw our terminal side. Now this third one, 990 degrees. All right. Well, we know here's 90 because we're positive, 180, 270 down here. Okay, so this would be 360. All right. Well, then we'd have to keep going, right, to get to 990. So if I go around again, where am I at? If I go around one more time, that would be 720 degrees, right? Okay, so we've gone around once, gone around twice, okay, and then what would be 3 times around? 360, 720. If we add 360 to 720, we'd be at 1,080 degrees. All right, well, we're not going around 3 full times then, are we? Okay, so let's see. This is 720, so this would be 810, and which means this is 900 here then, isn't it? Okay, so where's 990 going to be at? Yeah, right here in the negative y-axis. Right? So it's going to go to here. So we have our initial side, and then our terminal side is going to be the negative y-axis. Right, to get to positive 990 degrees. Right. So I'm showing these, just it might help you if you keep labeling them as you go around, just to show where they're at. Okay. Easy. Okay. All right. Next thing is then finding what are called coterminal angles. Now, coterminal angles are angles that actually they terminate at the same spot. Right? So they terminate at the same spot. So here they show the example of 120 degrees and negative 240 degrees. If I was to draw those two angles, they would terminate at the exact same spot. Right? Over here in the second quadrant. Right? So we say they are coterminal angles because of that. Right? And so they differ by multiples of 360 degrees because all the way around the circle is 360. Right? So sometimes you might have to go more than 360 degrees to find angles that are coterminal. Well, there's always 360 degrees, but they could be more than, it could be 360 apart, or they could be 720 degrees apart, or 1,080 degrees apart. Okay? But multiples of 360 degrees. Okay? So here they give us the angle of 65 degrees, and they want us to find a positive and a negative angle that are coterminal with it. So this is very simple. All we need to do to find coterminal angles is add 360 degrees or subtract 360 degrees from that angle. All right. So 425 degrees and negative 295 degrees, those are coterminal angles also. So if I graphed all of them, then they would all terminate in this spot here where we have 60 degrees, or then 425 degrees would terminate here, and negative 295 degrees. Those are all going to terminate at that same spot. Okay. So just the one we go around one time plus to here for 425, and for negative 295 we start here and just go this way. Okay. So they just differ by multiples of 360 degrees. Because if I wanted to get from 425 to negative 295, I'd have to subtract 360 twice. So anytime then this angle they want us to find coterminal with, if it's bigger than 360 or smaller than negative 360 degrees, then to get to a positive or a negative, you're going to have to do it more than once. So for instance, here we have 410 degrees. And we want a positive and a negative angle that are coterminal with it. So if we take 410 and add 360, all right, we're now at 770. All right, great. Okay, there's our positive. But if we're at 410 and we subtract 360, well, that's still at 50 degrees. All right, that's still a positive one. So to get to the negative one, I'm going to have to subtract 360 a second time. So for this answer, we have an option. This could be my positive one, or I could say that this is my positive one. Either one of them could represent the positive angle that's coterminal with 410 degrees. But because this is bigger than 360, I had to subtract 360 twice to get the coterminal angle that is less than 0, so the negative one. So all we need to do is add or subtract 360 degrees until we get there. Right. Okay, so find these. All right, next thing is called reference angles. All right. A reference angle is an angle that is less than 90 degrees, so it's acute. Okay. And it's between the terminal side and the x-axis. Okay, so a reference angle is less than 90 degrees, and it's the angle that takes me from the terminal side to the x-axis. So that could be the positive x-axis or the negative x-axis, depending upon where the angle is. So less than 90 degrees. And it is the distance from the terminal side to the positive x-axis. All right, so I'm actually going to draw these angles to help us to see it. Now you don't have to, okay? So if you understand it well enough that you don't need to do that, then that's fine. But I'm going to draw them first of all, just so we can see them. All right, so letter A, we have a 135 degree angle. So we know it's positive, so we know it's positive 90, 180, 270, and so on. Right? So when I draw this angle, it's going to be in the second quadrant, and it's 135 degrees this way. So the reference angle then is the distance from the terminal side to the x-axis. So we're talking about this area here. All right. So how far is it from here to here? How far is it from where it terminates to the x-axis? So in this case, we just do 180 minus 135. Okay, so our reference angle for this one is 45 degrees. Okay. Where it terminates to the x-axis. Okay. So negative 105 degrees. So we're going negative 90, negative 180, negative 270, all right, and so on. So negative 105 is going to be here, all right? So it's negative 105 degrees. So we want to find this distance here, all right? What is that angle represented there? What is this angle? What's that angle, right? So we want to get from 105. So, I don't like working with negatives. Okay, so I can just think of this as how far is it from 105 to 180? And that would be 75 degrees. Okay. Letter C, 325 degrees then. All right, so we're talking about positive. So 325 is going to be in the fourth quadrant, somewhere in this vicinity here. So we're trying to find this distance here. Right? How far is 325 from the x-axis? Well, the x-axis then would be what? 360. All right? So if I need to do some subtraction then, in this case, we'll do 360 minus 325. So our reference angle would be 35 degrees. Sometimes it helps to draw it, okay? But you don't have to draw it, okay? So, but just the biggest thing is to remember is it's got to be positive, okay? And it's acute, so it's got to be less than 90 degrees. So if you ever get a reference angle that's negative or bigger than 90 degrees, then you know you've made a mistake there. All right. So let's just do A and B here, and let's check it out. All right. So we've looked at three things so far. We got one more to look at, but so drawing our angles. Make sure that you do, when you draw your angles, you do show the direction, okay, that it's going. So you have to have an arrow there along with both pieces. Right? We talked about coterminal angles, which differ by multiples of 360 degrees. Okay. Reference angles less than 90 degrees from the terminal side to the x-axis. All right. Could be positive or negative x-axis, depending on where the angle's at. All right. And then the last thing is we're going to we're given a point in the coordinate plane. We're going to find the 6 trig functions for that point. Now, I've varied in the ways I've approached this in the past, all right? And I'm actually going to erase some of the stuff or delete some stuff I put on here because I think that it tends to sometimes confuse people if we just start plotting the points, all right? And so we'll talk about the point where it's at, but when we find the trig functions, we're not going to use it. So, all right, so sine, cosine, and tangent, when we're talking about a point on the coordinate plane, are defined a little bit differently, but in reality they're not. Okay? Sine is defined as y over r. So we have the point xy. So sine is y over r. Cosine is x over r, and tangent is y over x. Well, what is r? R is the square root of x squared plus y squared. So basically all of this is the Pythagorean theorem. Okay? That if I plot the point xy in the coordinate plane, then I have a right triangle here with the absolute value of x, absolute value of y, and then r is just the hypotenuse of the right triangle. So we just use the Pythagorean theorem to find r. Right? So if I'm given a point xy, r is equal to the square root of x squared plus y squared, and here's how we define sine, cosine, and tangent. Well, that means then that cosecant, secant, and cotangent then would just be the reciprocal of those three. All right. So here they give us the point negative 6, 9 is a point on the terminal side of P in standard position. Find the exact value of the 6 trig functions for theta. Now, you don't have to draw this. I'm just going to draw this just for the moment, just to see it. That we have, if I plotted this point then I would have this triangle that I'm working with. Right? And when we work with that triangle, always cosine always goes with x. Sine always goes with y, because we're working with this as our theta. So the opposite side is always my y value, and the adjacent side is always my x value. So to find sine, cosine, and tangent, right, y is always going to be the opposite side. X is always going to be the adjacent side. So we associate them that way. So sine of theta equals, well, we got to find something first, right? Okay, so let me get rid of this for a second. All right, like I said, here's our theta. So this is 9. This is -6. All right, and then the first thing I have to do then is I have to find r. So r equals the square root of x squared plus y squared. And r is always positive because it's a distance, okay? So we get 36 plus 81, which is what? 117, right? Okay, so r is equal to the square root of 117. Now I think we can simplify that, but with that being a complicated one, we're just going to leave it, okay? And so when we write our ratios, we're just going to leave it in the denominator and call it good. Okay. So sine of theta. Sine is y over r. So y is 9, r is square root of 117. Just going to leave it like that. Cosine is x over r. X is -6 over square root of 117 then. Tangent is y over x. So that's 9 over -6, or -3/2. Just make sure you do simplify any of the easier fractions. All right, and then we need the other 3. Well, let's see, for the other 3 then, let me make this smaller. All right. So cosecant is the reciprocal of sine, so that's going to be the square root of 117 over 9. Secant, which is the reciprocal of cosine, negative square root of 117 over 6. And cotangent, the reciprocal of tangent, is -2/3. So we're still working with a right triangle basically when we're doing these, but like I said, I would find r and then just put things in where they need to go. You don't have to draw a picture of it, because like I said, I found that people don't draw the pictures very well. Okay, that what will happen is, even if they plot the point right, that they'll then draw the picture or draw the triangle here instead sometimes. Right? Well, what happens then? Now my adjacent side is 9 and my opposite side is -6, and then that's wrong. Okay, it mixes up. So if I just go by the fact that y is with sine, y is the opposite side, x is the adjacent side, then I never get those things confused, and I don't have to worry about that. So, okay. All right.